What if I told you there was a NASCAR mechanic who figured out how to make an engine grow bigger during a race? Not before the race, not after, but literally while the car was screaming around the track at 200 miles per hour. This wasn't some fancy engineering breakthrough or revolutionary new technology. This was wax, common, everyday wax. And it worked so well that when NASCAR officials finally caught on, they couldn't believe what they were seeing. Picture this. It's February 20th, 1983, the Miller High Life 500 at Richmond Fairgrounds Raceway. Richard Petty's famous number 43 STP Pontiac rolls into victory lane after dominating the field. The King had just scored his 198th career victory, and the crowd was going wild. But something wasn't right. A sharp-eyed NASCAR official noticed the left side tires looked slightly off. Just a hair too big for what was supposed to be on that car. That tiny observation would unravel one of the most ingenious cheating schemes in NASCAR history. This is the story of how Maurice Petty, engine builder extraordinaire and brother to the King himself, used melting wax to create what might be the most audacious engine trick ever attempted in professional racing. A trick so simple, it sounds stupid. So effective, it won races. And so brazen that when NASCAR figured it out, they didn't know whether to be furious or impressed. To understand why anyone would stuff wax into engine cylinders, we need to travel back to NASCAR in the early 1980s. This was the era of the big block engines, when displacement was king and every cubic inch counted. NASCAR had strict rules about engine size, 358 cubic inches maximum for Winston Cup cars, not 359, not 360, exactly 358. Teams would get their engines inspected before qualifying, and any motor over that limit meant disqualification. No exceptions. But here's the thing about NASCAR in those days. The inspection happened before the race. Once you passed tech, your engine was assumed to be legal for the duration of the event. And that's where Maurice Petty saw an opportunity. What if an engine could pass inspection at 358 cubic inches, then somehow grow bigger during the race itself? The physics were simple but brilliant. NASCAR inspectors checked displacement using a pump that measured the volume of each cylinder. They'd turn the crankshaft to bottom dead center, pump in fluid, and measure exactly how much each cylinder held. Add them all up and you got your total displacement. The entire inspection took maybe 20 minutes, but Maurice realized something crucial. The inspection happened with a cold engine. Here's where it gets interesting. Maurice and his team at Petty Enterprises had been experimenting with different ways to extract more power from their engines. They'd tried every trick in the book, radical cam profiles, exotic fuel additives, even supposedly running left-side tires that were a different compound than the right. But the displacement limit was killing them. Other teams, particularly Junior Johnson's operation, seemed to have found extra horsepower somewhere. The Pettys needed an edge. The solution came from an unexpected place. Maurice was working on an engine one day when he noticed how paraffin wax behaved when heated. It would melt completely into a liquid, taking up less space than when solid. More importantly, it would stay liquid as long as the temperature remained high. That's when the light bulb went off. What if they filled the combustion chambers with carefully measured amounts of wax before inspection? The cold wax would take up space, reducing the measured displacement. The engine would check in at a legal 358 cubic inches. But once the race started and the engine reached operating temperature, typically around 200 degrees Fahrenheit for the coolant and much hotter in the combustion chambers, the wax would melt. It would liquefy, get blown out the exhaust, and suddenly those combustion chambers would be bigger. The displacement would jump from 358 to approximately 373 cubic inches. 15 cubic inches might not sound like much, but in NASCAR terms, it was massive. The general rule of thumb was that every cubic inch was worth about 2 horsepower at peak power. So we're talking about a 25 to 30 horsepower advantage. in a sport where races were often decided by fractions of a second. That kind of power difference was like bringing a gun to a knife fight. The preparation was meticulous. Maurice and his team would carefully measure out specific amounts of wax for each cylinder. Too much, and the engine wouldn't pass inspection. Too little, and they wouldn't get the power gain they needed. They had to account for the shape of each combustion chamber, the valve pockets, even the spark plug position. Everything had to be perfect. The wax had to be a specific type too. Regular candle wax wouldn't work. It would leave residue that could foul the spark plugs or damage the valves. They needed something that would melt cleanly and completely, leaving no trace behind. After extensive testing, they settled on a particular grade of paraffin wax with a melting point of about 140 degrees Fahrenheit. Low enough to liquefy quickly once the engine warmed up, high enough to stay solid during inspection. Installing the wax was an art form. They'd warm the wax just enough to make it pliable, then carefully press it into the combustion chambers. It had to conform perfectly to the chamber shape without any air pockets. Then they'd let it cool and harden before installation. The whole process added hours to engine preparation, but the payoff was worth it. On race day, the engine would fire up normally. For the first few laps, it would run like a standard 358. But as the temperatures climbed, magic happened. The wax would begin to melt, first softening, then liquefying completely. By lap 10 or 15, it would be gone entirely, blown out through the exhaust system in microscopic droplets. And suddenly, Richard Petty was driving a 373 cubic inch monster, while everyone else was stuck at 358. The beauty of the scheme was its simplicity. No moving parts to break, no complex mechanisms to fail, no electronic wizardry that could be detected. Just wax that disappeared without a trace. By the time the race ended, there was literally no evidence. If NASCAR decided to check displacement after the race, which they rarely did, the engine would measure exactly what it was supposed to be. 373 cubic inches of American thunder. For months, maybe even years, the trick worked perfectly. Richard Petty's cars seemed to have extraordinary power, especially in the middle and late stages of races. Other teams couldn't figure it out. They'd dyno test their engines against the Petty motors before events and find similar power numbers. But on track, especially after 50 or 100 miles, the 43 car would pull away on the straights like it had nitrous. Junior Johnson, himself no stranger to creative rule interpretation, later admitted he knew something was up. That damn Petty motor would come alive after about 20 laps, he said in an interview years later. We tore our engines apart looking for what they had. Never found it because we were looking for mechanical stuff. Never occurred to us they were using something that disappeared. But here's where Maurice's genius really showed. The wax trick wasn't the only thing they were doing. Petty Enterprises was known for pushing every boundary, testing every limit. They ran trick carburetors, special fuel mixtures, and yes, those oversized left-side tires that would ultimately be their downfall. The wax was just one weapon in an arsenal of speed secrets. It was hidden in plain sight among a dozen other innovations, some legal, some decidedly not. The technical brilliance extended beyond just the wax selection. Maurice had to calculate exactly how the increased displacement would affect the engine's other parameters. A bigger displacement meant different air-fuel requirements, altered ignition timing needs, and changed exhaust scavenging characteristics. The camshaft profile that worked perfectly for 358 cubic inches might be completely wrong for 373. So they developed what were essentially two engine maps in one. The camshaft was ground with a profile that would work adequately at 358 cubic inches, but really come alive at 373. The carburetor was jetted rich enough to feed the bigger displacement once it emerged. The ignition curve was set to prevent detonation at either displacement. It was like building a transformer engine, one that could shift from mild-mannered qualifier to race-winning monster at will. The exhaust system played a crucial role, too. The headers and pipes were tuned for the larger displacement, which meant the engine was actually giving up some power during inspection and qualifying. But once the wax melted and the displacement increased, the exhaust tuning would be perfect. The engine note would literally change during the race, though with 40 other cars screaming around the track, nobody noticed. Testing this system was incredibly risky. They couldn't exactly roll up to a public test session with wax-filled cylinders. All development had to happen in secret, back at the Petty shops in Level Cross, North Carolina. They built a special dynamometer cell just for these engines, one that could simulate the heat cycles of a real race. Hour after hour, they'd run engines to destruction, perfecting the wax formula and installation technique. The data they collected was fascinating. The power curve would literally shift during a simulated race. At startup, 6 to 20 horsepower. After 5 minutes, 635. After 10 minutes, 645. By the 15-minute mark, with all the wax gone, they'd see a steady 650 horsepower. That 30 horsepower difference was like bolting a small motorcycle engine onto the car. In NASCAR's world of incremental gains, it was astronomical. But the real beauty was in the torque curve. The extra displacement didn't just add peak power, it fattened up the entire power band. The engine would pull harder out of corners, accelerate faster down straights, and maintain speed better in traffic. Richard Petty could drive differently than his competitors, using lines and techniques that only worked with that extra grunt. The 1983 season started brilliantly for Petty Enterprises. Richard won at Richmond in February using the wax-enhanced engine. The car was dominant, leading 207 of 400 laps. Nobody suspected a thing. The post-race inspection was routine: weight, height, template measurements. The engine wasn't touched. Another successful mission for Maurice's melting miracle, but NASCAR officials weren't stupid. They knew something was helping the Petty cars. They just couldn't figure out what. Dick Beatty, NASCAR's technical director at the time, had been watching the 43 car carefully. That's why he noticed those oversized left-side tires at Richmond. It was a minor infraction, really, worth maybe 1/10 of a second per lap. But it gave NASCAR the excuse they needed to dig deeper. The inspection that followed was unprecedented. NASCAR literally disassembled the entire engine, piece by piece. They measured everything: bore, stroke, rod length, compression height. And that's when they found it. The displacement was 373 cubic inches, not the legal 358. But how? The engine had passed pre-race inspection just 2 days earlier. Maurice Petty initially played dumb. Must be a measurement error? Maybe the engine got damaged during the race. Perhaps there was carbon buildup affecting the readings. But NASCAR kept digging. They examined the combustion chambers with a borescope and found tiny traces of wax residue in the valve pockets. Not much, just a few microscopic droplets that hadn't quite made it out, the exhaust. But it was enough. The confrontation was epic. Bill France Jr. himself got involved, flying down from Daytona to deal with the situation personally. The Pettys were NASCAR royalty. Richard was the sport's biggest star, the 7-time champion, the king. You couldn't just throw the book at them like some nobody team. But you also couldn't let this slide. The integrity of the sport was at stake. In the end, NASCAR fined Petty Enterprises $35,000, a massive sum in 1983. Richard was docked 104 points, though he kept the win. Maurice was suspended as crew chief for the rest of the Richmond race and the next race at Rockingham. But perhaps most importantly, NASCAR changed its inspection procedures. Random post-race engine displacement checks became standard. The wax trick would never work again. The racing world's reaction was mixed. Some were outraged at the blatant cheating. Others admired the creativity. Smokey Yunick, himself the master of creative rule interpretation, called it brilliant. He later claimed he'd thought of something similar, but never tried it because he assumed NASCAR would catch on immediately. Maurice had balls, Smokey said, huge ones. Other crew chiefs and engine builders immediately began experimenting with their own versions. Some tried different materials. There were rumors of teams using dry ice, liquid nitrogen, even mercury. But NASCAR was watching now. They instituted new procedures where engines would be run to operating temperature before displacement checks. The window had closed. The long-term impact was significant. The 1983 incident led to comprehensive changes in NASCAR's technical inspection process. They hired more officials, invested in better measurement equipment, and instituted random checks throughout race weekends. The days of run-what-you-brung creativity were ending. NASCAR was becoming more professional, more standardized, more like other major sports. For Maurice Petty, the incident was both an embarrassment and a badge of honor. He'd been caught, yes, but he'd also proven himself as one of the most innovative minds in racing. In later interviews, he never fully admitted to the wax trick, always maintaining that any displacement discrepancy was unintentional. But his sly smile told a different story. Richard Petty's reaction was typically diplomatic. The king claimed he knew nothing about the wax, that he just drove what Maurice built. Whether that was true or not, only Richard knows. But considering how intimately drivers knew their cars in those days, how attuned they were to every vibration and sound, it seems unlikely he didn't notice his engine magically gaining power during races. The technical legacy lives on. Modern NASCAR engines are inspected with such scrutiny that a trick like this would be impossible. Displacement is checked hot and cold, before and after races. Engines are sealed between qualifying and racing. Electronic monitoring tracks every parameter in real time. The romantic era of mechanical creativity is over, replaced by digital precision. But the story endures because it represents something fundamental about racing spirit. That drive to find any advantage, to push any boundary, to interpret any rule in your favor. Maurice Petty wasn't trying to cheat so much as he was trying to win. In NASCAR's world, that distinction matters. The wax wasn't about breaking the rules, it was about finding the rules' limits. Young engineers today study the wax trick not to copy it, but to understand the mindset behind it. How do you look at a problem differently? How do you find solutions in unexpected places? How do you hide in plain sight? These are valuable lessons that extend far beyond racing. The numbers tell the real story. That 373 cubic inch engine, when properly tuned and fed, was producing nearly 650 horsepower and 520 pound-feet of torque. The legal 358 would have made about 620 horsepower and 495 pound-feet. Over a 500-mile race, that difference added up to seconds per lap, minutes over the full distance. It was the difference between winning and finishing fifth. Let's talk about the actual mechanics of how this power increase worked. Displacement is simply the volume swept by all the pistons during one complete cycle. It's calculated by measuring the bore, cylinder diameter, and stroke, how far the piston travels, then multiplying by the number of cylinders. A typical NASCAR engine of that era had a bore of 485 inches and a stroke of 3.25 inches. That gave you 358 cubic inches across 8 cylinders. But when the wax melted, it effectively increased the combustion chamber volume. The bore and stroke didn't change, but the space above the piston at top dead center got bigger. This lowered the compression ratio slightly, but increased the overall displacement. It was like giving the engine bigger lungs. More air and fuel could be packed in, creating a bigger explosion, generating more power. The thermodynamics were fascinating too. The wax actually helped during warm-up by retaining heat in the combustion chambers. This meant the engine reached operating temperature faster, reducing wear and improving early race performance. As the wax melted, it would momentarily create a super-rich mixture as it burned off, adding a tiny bit of extra fuel to the combustion process. Every little bit helped. Modern engine builders look at what Maurice accomplished and shake their heads in amazement. Today's NASCAR engines are masterpieces of precision, with tolerances measured in 10,000ths of an inch. But they're also heavily restricted, with spec parts and sealed components. There's no room for creativity like the wax trick. In some ways, racing has lost something magical. The cost analysis is interesting too. That $35,000 fine? In today's money, that's about $100,000. But consider what that bought. If the trick worked for even 10 races before being caught, and each win was worth hundreds of thousands in prize money and sponsorship bonuses, the investment paid off handsomely. It wasn't stupid at all. It was brilliant business. The human element can't be ignored either. Imagine being the crew member tasked with installing the wax, the pressure of getting it exactly right. Too much in one cylinder, and the engine fails inspection. Too little, and you've given up precious power. The stress of knowing that NASCAR could decide to do a hot displacement check at any moment. The relief when another race passed without detection. These were people pushing themselves as hard as the machines they built. There's also the question of how many other teams were doing similar things. The Pettys got caught, but were they alone? Unlikely. The 1980s were the Wild West of NASCAR innovation. Teams were running acid-dipped bodies to save weight, hydraulic systems that would lower the car during races, and fuel additives that bordered on rocket propellant. The wax trick was just one chapter in a book of creative engineering. Some historians argue that tricks like this actually advanced the sport. By pushing boundaries, teams forced NASCAR to improve its inspection processes, develop better rules, and ultimately create a more level playing field. The cat-and-mouse game between racers and regulators drove innovation on both sides. Today's sophisticated technical inspection process exists because of schemes like Maurice Petty's wax. The international racing community watched with fascination. Formula One teams, used to their own Byzantine technical regulations, were impressed by the simplicity. Sports car teams wondered if similar tricks might work in endurance racing. The wax story spread globally, becoming part of motorsport folklore. But perhaps the most important lesson is about innovation under constraints. Maurice Petty didn't have unlimited resources. He didn't have advanced computer modeling or exotic materials. He had wax, physics, and imagination. He solved a complex problem with a simple solution. That's engineering at its purest, not the most complex answer, but the right answer. The trick also highlighted a fundamental tension in racing. Rules are meant to ensure fair competition, but racing is about winning. Every team interprets rules to their advantage. The difference between innovation and cheating often comes down to whether you get caught. Maurice Petty got caught, but only after potentially years of success. Consider the ethics for a moment. Was this cheating? Absolutely, by the letter of the law. Was it wrong? That's a harder question. In NASCAR's culture, if you're not pushing the rules, you're not trying hard enough. The Pettys were trying very, very hard. They were racers doing what racers do, finding speed wherever it existed. The wax revelation also changed how people viewed Richard Petty's career. Some wondered how many of his 200 victories were aided by creative engineering. Others argued it didn't matter. Every top team was bending rules somehow. The King's driving skill was undeniable, regardless of what was under the hood. But the shadow of doubt was cast. Mechanically, the aftermath was significant. NASCAR didn't just check displacement more carefully, they mandated specific measurement procedures. Engines had to be checked at specific temperatures. Measurement equipment had to be calibrated before each use. A paper trail of every measurement was required. The bureaucracy of speed was born. The story resonates today because it represents a lost era. Modern racing is incredibly professional, with corporate oversight and digital scrutiny. But in 1983, a guy with some wax and a clever idea could outsmart the entire system. There's romance in that. There's beauty in the simplicity. There's something deeply American about using ingenuity to beat the establishment. The technical specifications of that era seem quaint now. Those 650 horsepower engines? Today's NASCAR Cup engines make 750 horsepower while being more restricted than ever. The technology has advanced, but the spirit of innovation has been regulated into submission. Some say that's progress. Others mourn the loss of creativity. The Petty Engine Shop in Level Cross, North Carolina, still stands. It's a museum now, full of historic cars and memorabilia. But if you know where to look, you can still see the dynamometer room where they tested those wax-filled engines. The concrete walls absorbed the sound of thousands of hours of testing, of engines pushed to destruction in the pursuit of speed. Those walls keep secrets. Maurice Petty passed away in 2020, taking many of those secrets with him. He never fully detailed how the wax trick worked, how many races it won, or what other innovations he developed. His autobiography mentions the incident briefly, almost dismissively. But those who knew him said he was proud of the creativity, if not the outcome. The lasting impact extends beyond just NASCAR. The wax engine story is taught in engineering schools as an example of lateral thinking. Business schools use it as a case study in competitive advantage and risk management. It's become bigger than racing. It's about human ingenuity itself. When you really think about it, the absurdity is beautiful. In an age of increasing complexity, when racing teams employed dozens of engineers with advanced degrees, one mechanic with wax outsmarted them all. It's David versus Goliath, if David's slingshot was powered by melting paraffin. The stupid simplicity was its genius. So what can we learn from Maurice Petty's wax cylinder trick? First, that innovation doesn't always mean complexity. Sometimes the best solution is embarrassingly simple. Second, that rules are meant to be tested, boundaries pushed, limits explored. That's how progress happens. Third, that in racing, as in life, it's not cheating until you get caught. And even then, if it's clever enough, people might just admire you for trying. The wax engine remains one of NASCAR's greatest technical mysteries and scandals. It represents a time when racing was more art than science, when creativity mattered as much as cubic dollars. It was stupid, brilliant, illegal, and beautiful all at once. It was everything racing should be: dangerous, innovative, and slightly insane. Today's engineers, armed with computational fluid dynamics and finite element analysis, might scoff at such a crude trick, but they'd be missing the point. Maurice Petty didn't have those tools. He had observation, intuition, and the courage to try something everyone else would dismiss as too simple to work. That's not stupid. That's genius. The numbers never lie. 15 extra cubic inches, 25 to 30 horsepower. One brilliant idea. Zero evidence after the checkered flag. These are the statistics of one of racing's greatest innovations, hidden in plain sight until one observant official noticed a tire that looked just a little too big. In modern NASCAR, with its spec engines and sealed components, such creativity is impossible. Every part is monitored, measured, and regulated. The romance of the garage inventor has been replaced by corporate engineering departments. Progress? Perhaps. But something indefinable has been lost. That spark of individual brilliance that could change everything with something as simple as wax. Looking back, the wax cylinder trick represents the end of an era. It was one of the last great mechanical deceptions before technology made such schemes impossible. It stands as a monument to human creativity, a reminder that sometimes the stupidest sounding idea is actually brilliant. Maurice Petty proved that, with enough imagination, you could make an engine grow during a race. You just needed the right temperature, the right material, and the audacity to try. What's your favorite piece of racing innovation that pushed the rules too far? Drop a comment below and share your thoughts on whether creative rule bending is cheating or just clever engineering. And if you enjoyed this deep dive into one of NASCAR's most ingenious technical tricks, make sure to subscribe. We've got plenty more stories of brilliant engineering disasters, revolutionary innovations, and the machines that changed everything. Until next time, remember, in racing, if you're not bending the rules, you're not trying hard enough. Keep those engines running and keep pushing those boundaries.